This video we'll be looking at solving a differential equation, and we'll be integrating skills from other aspects of the curriculum in order to advance the solution. So we'll start off with part A, which is to apply integration by parts and prove a particular result. So in part A, we have following. So we want to integrate x cosec square x plus pi by 6. We're going to choose u as x and d dash as cosec square x plus pi by 6. When we differentiate u, we get 1. When we integrate cosec square, we get minus cot x plus pi by 6. So applying the formula, we're going to get integral is equal to uv. So that's going to be minus x cot x plus pi by 6, then minus the integral of u dash v. So that's minus cot x plus pi by 6 dx. We know that cot is cos over sine. So this is going to be minus x cot x plus pi by 6 plus the integral of cos x plus pi by 6 divided by sine x plus pi by 6 dx. When we write it that way, we see that it follows the Lund rule. When we differentiate sine, we get cos. So we can apply the Lund rule to integrating, and so we'll end up with this as minus x cot x plus pi by 6 plus Lund sine x plus pi by 6 plus c. If we now check our results, we note that this is now satisfied. So our answer is exactly the same as what is required. So we continue now with the part B, solve the differential equation sine square x plus pi by 6 dy dx is equal to 2xy y times 2xy bracket y plus 1. So the approach here is to separate and integrate. We bring all of the y terms onto one side with dy dx and all of the x terms onto the other side with dx. So we bring all of the y terms with dy and all of the x terms with dx. So in part B, we're going to separate the x's. So we're going to have separate the y. So we're going to have 1 over 2y bracket y plus 1. Try this a little bit better. 1 over 2y bracket y plus 1 dy is equal to x over sine square x plus pi by 6 dx. And then we will integrate. If we rewrite the right-hand side, this is the integral of x times cosec square x plus pi by 6 dx. And we see how that ties into the result that we have previously worked out. So this is the same as the answer that we have right here on part A. So what we need to now do is we need to focus on the left-hand side. So we're going to look at 1 over 2y, y plus 1. In order to integrate that, we're going to use partial fractions. All right, so we're going to have 1 over 2y, y plus 1 is equal to a over 2y, b, y plus 1. So we're going to have 1 is identical to a lots of y plus 1 plus b lots of 2y. We're going to use Judy's substitution. So we're going to let y equal minus 1. This implies that 1 is equal to minus 2b, or b is equal to minus a half. Then we're going to let y equal 0. And this implies that 1 is equal to a. So here we're going to have 1 over 2y minus 1 over 2y plus 1. All right. So now we can integrate the expression on the left-hand side using that result. So the integral of 1 over 2y, y plus 1 dy is equal to the integral of 1 over 2y minus 1 over 2y plus 1 dy. We can factor the half out, and then this is going to be half integral of 1 over y minus 1 over y plus 1 dy. So this is going to be half, and then that's all into ln y minus ln y plus 1. If we tidy that up a little bit, we're going to have this is equal to half ln y over y plus 1. So that is the left-hand side. So we want to now connect that. If we go back up, we now want to connect that to the answer that we have on the right-hand side. The minus x cot x plus pi by 6 plus ln sine x plus pi by 6. So all of this is equal to minus x cot x plus pi by 6 plus ln sine x plus pi by 6, and then plus c. So if we go back to the question here, so they want us to, so we have shown what is required, that when we solve the differential equation, we get half ln y over y plus 1 equal minus x cot x plus pi by 6 plus ln sine x plus pi by 6 plus c. So that part is fine. And then now what we need to do is we need to use the initial condition and find the exact value of y when x is equal to pi by 12. So we need to solve for c when x is 0, y is 1. So let's do that part first. So now do this. So when x equals 0, y is equal to 1. So on the left-hand side, we're going to have half ln 1 over 2 is equal to minus 0 dot pi by 6 plus ln pi by 6. So half ln a half is equal to the sign of pi by 6 is going to be a half. So that's ln of a half plus c. So when we rearrange that, we have c is equal to half ln a half minus ln a half, which is equal to minus a half ln a half. So we can pull that all together now as one expression. And then we're going to have, so this now is going to be, instead of c, we can erase this. And then we have minus a half. So that's going to be, okay. So now if we go back to the question, we want to find the exact value of y when x is equal to pi by 12. So let's look at where we are now. Okay, so this is our journey so far. We integrated x cos x squared x plus pi by 6, and then we solved the differential equation. We solved for c, and now we want to use this particular solution in order to solve for the exact value of y when x is pi by 12. Okay. So here, so now I want to continue from here. So we're going to now let x be pi by 12. Then x equal pi by 12. So we're going to have so let's bigger. So if x is equal to pi by 12, we're going to have half ln y plus 1. So half ln y or y plus 1. Here, we're going to have minus pi by 12, pi by 12 plus pi by 6. That's equal to minus pi by 12 cut pi by 12 plus pi by 6. And then that would be ln sine pi by 12 plus pi by 6. Plus ln sine pi by 12 plus pi by 6. And then minus half ln over half. So we have half ln y over y plus 1 is equal to minus pi by 12. And then this would be times 1 over tan. And that would be pi by 12 plus pi by 6 is going to be pi by 4. And then sine pi by 4. And that's ln over half. So this is going to be tan pi by 4 is 1. So this is also minus pi by 12. And then sine pi by 4 is going to be ln 1 over root 2 minus a half ln of a half. Now, of course, 1 over root 2 is 1 over 2 to the half. So these two terms are equivalent. So that will cancel out that. So what we end up having is a half ln y over y plus 1 is equal to minus pi by 12. Therefore, ln y over y plus 1 is equal to minus pi by 6 when we times by 2. So therefore, y over y plus 1 is equal to e to the minus pi by 6. So if we now rearrange that, we have y is equal to y plus 1 e to the minus pi by 6. And then y is equal to y e to the minus pi by 6 plus e to the minus pi by 6. So solving for, so if we bring all of the y terms together, we're going to have y minus y e to the minus pi by 6 is equal to e to the minus pi by 6. So that's just going to be y bracket 1 minus e to the minus pi by 6 is equal to e to the minus pi by 6. And then if we continue over here, so therefore y is equal to e to the minus pi by 6 divided by 1 minus e to the minus pi by 6. So if we times that by positive e to the minus pi by 6, or we get y is equal to 1 over e to the pi by 6 minus 1. Okay, and that completes part C of the journey.